Welcome to this session. This session is solved the third order differential equation by matrix method. So find the general solution to the differential equation by matrix method. So that's the problem we are invested in solving. So please write the question. Fine. So the first step to do is to write the highest derivative on one side and then take other terms on the opposite side, or simply means make the third order derivative term the subject in this equation. So solution. Make this the subject. So I'll have d cubed x dt cubed equals to, now you start with this term without the derivative, negative 12x plus 4 dx dt plus 3 d squared x dt squared. So that's step one. Make the highest derivative term the subject. And then the next step, you now introduce a new variable. Let x to be x1. And because we know that dx dt can be written as x prime dx squared dt squared is x double prime, and d cubed x dt cubed can be written as x triple prime, then this equation is the same thing as writing, so letting this x to be x1, so this will be d cubed x1 over dt cubed equals to minus 12 x1 plus 4 dx1 dt plus 3 d squared x1 dt squared. Now, with this notation, we can say it's the same as x triple prime, x1 triple prime is minus 12 x1 plus 4 x1 prime plus 3 x1 double prime. Call this one star. Fine. So I want us to differentiate both sides of this equation. So we say x equals to x1, then it's the same thing as saying x prime is equals to x1 prime. So that's what we have done here. And then next thing, you say let x1 prime be another new variable, x2. And now this one, you call it question 1. Okay, so differentiating both sides of 1, we get, so we'll have x1 double prime, because this is already prime, will be the same as x2 prime. Now we also let this x2 prime be another new variable, x3. So let x2 prime be another new variable, x3, and call this one question 2. Then Also do the same step we have done here, differentiating both sides of 2, we get x2 double prime is the same as x3 prime. But you see, when you say you are differentiating this one again, it's the same way as differentiating this one. So that means x3, note that x2 double prime is the same thing as saying x1 triple prime. Because it's like you are also differentiating this one also the second time. So this is the same as what you are calling x3 prime. So then if we replace star, which is x1 triple prime by x3 triple prime, there will be no mistake. So then star becomes, so the left hand side will be x3 prime, and then this will be minus 12x1. You see x1 prime by definition in equation 1 is x2. So where there's x1 prime, we put x2. So we'll have 4x2. And then x1 double prime is the same as x2 prime, and x2 prime is the same as x3. So this is 3x3. This one you call it equation 3. So that's now this what you have. So we have in equation 1 is x1 prime is x2. So we write x1 prime and write 0x1 plus x2 plus 0x3. And then in 2, x2 prime is the same as x3. So I can write it as 0x1 plus 0x2 plus x3. And then in equation 3, we have x3 prime is minus 12x1 plus 4x2 plus 3x3. So we have a system of 3 linear differential, first order differential equations, which can be written in matrix form as x1 prime, x2 prime, x3 prime is given by 0, 1, 0, 0, 0, 1, minus 12, 4, and then 3, and then you multiply by x1, x2, x3. So this is what we call the matrix equation. Now, this is the structure of this general form. X dot equals to AX, where this is the X vector, this is the A matrix, and then this is the X dot. So we say here, A matrix is 0, 1, 0, 0, 0, 1, minus 12, 4, and 3. So which means then now we go into the eigenvalues step. So eigenvalues. So we solve A minus lambda I, determinant is 0. So minus 0 minus lambda, 1, 0, 0, 0 minus lambda 1 minus 12, 4, and 3 would give us 0. Be the same as determinant of minus lambda, 0 minus 12, 1 minus lambda, 4, and then 0, 1, 3 minus lambda. This will give us 0. So expanding along the first row will give us negative lambda, determinant of minus lambda, 1, 4, 3 minus lambda. The sign of this element is negative, so negative 1 into 0 minus 12, 1, 3 minus lambda should give us 0. So we'll have negative lambda. So this will be lambda squared minus 3 lambda minus 4 minus 1 into 0 by this will be 0 minus 12, so it will be plus 12 equals to 0. So that will give us minus lambda cubed plus 3 lambda squared plus 4 lambda minus 12 is 0. And then we can divide through by negative 1 to get lambda cubed minus 3 lambda squared minus 4 lambda plus 12 equals to 0. So this is the characteristic equation. And then we should find out that if you do factorization of this cubic, you will get lambda minus 2, lambda plus 2, lambda minus 3 equals to 0. Please do that factorization. And then, so this means lambda 1 is negative 2, lambda 2 is 2, and lambda 3 is positive 3. So next, eigenvectors. So for the first eigenvalue, negative 2, so expect the vector to be of the form u1, u2, u3. So this equation must be satisfied. The A matrix is given by 0, 1, 0, 0, 0, 1, minus 12, 4, 3, and then u1, u2, u3, which will be given by minus 2, u1, u2, u3. So this will give us u2, and then u3, and then we have minus 12 u1 plus 4 u2 plus 3 u3 should give us minus 2 u1 minus 2 u2 minus 2 u3, from which we should be able to get u2 is minus 2 u1, u3 is minus 2 u2, and then minus 12 u1 plus 4 u2 plus 3 u3 is minus 2 u3. So this equation 1, this equation 2, this equation 3. So if we let u1 to be t in equation 1, where t is any non-zero real number, then u2 would be minus 2t. And using that value in equation 2, u3 will be given by minus 2 times 2 minus 2t, which is 4t. So thus the u1 vector will be u1, u2, u3. So t minus 2t, 4t, which is 1 minus 2, 4, t. And when t is 1, then u1 will be 1 minus 2, 4. Now, when you get the eigenvector, you get the corresponding solution. So this means x1 of t is u1 e raised power lambda 1t, which is 1 minus 2, 4, e raised power minus 2t. So this is the solution for x1. And then for lambda 2 equals to 2, so we'll have the A matrix is 0, 1, 0, 0, 0, 1, minus 12, 4, positive 3. The vector will still be u1, u2, u3 equals to 2, u1, u2, u3. So which will give us u1, u3 minus 12 u1 plus 4 u2 plus 3 u3 to give us 2 u1. Remember, this is u2, not 0 times, so this is u2. And then 2 u2, 2 u3. And when you equate this matrix equation means u2 is 2 u1, u3 is this what this equation means. So call this 1, call this 2, call this 3. Now when you let u1 to be s, where s is a non-zero real number, from this first equation, so u2 will be 2s, and u3 from this second equation will give us 4s. So the vector u2 is u1, u2, u3 are given by s, 2s, 4s, which is 1, 2, and 4 times s. And for simplicity, letting s to be 1, u2 will be 1, 2, then 4. So which means x2 solution will be u2 by definition e raised power lambda 2t, which will be 1, 2, 4, e raised power 2t. So call this one double star. And lastly, for lambda 3 equals to 3, then we have a 0, 1, 0, 0, 0, 1, minus 12, 4, 3. The vector will still be u1, u2, u3 equals to 3 times u1, u2, u3. So simplifying, we'll have u2, u3 minus 12u1 plus 4u2 plus 3u3, I will give us 3u1, 3u2, 3u3, from which u2 is 3u1, u3 is 3u2, and then minus 12u1 plus 4u2 plus 3u3 is 3u3. Question 1, question 2, question 3. So from 1, let u1 be, say, r, where r is a non-zero real number. So that means that u2 will be 3r and u3 will be 3 times 3r, which will be 9r, using equation 2. So the vector u3 will be u1, u2, u3, given by r, 3r, 9r, which will be 1, 3, 9 times the non-zero real number r. So when we let that r to be 1, then u3 will be the vector 1, 3, 9. So, which means x3 of t is u3 e raised power lambda 3t, which is 1, 3, 9 e raised power 3t. So call this one triple star. Now, the general solution is given by linear combination of x1, x2, and x3. So by superposition principle, the general solution to the equation x dot equals to ax is x of t, c1 x1 of t plus c2 x2 of t plus c3 x3 of t. So we should be given by c1. So x1 we have 1 minus 2, 4 e raised power minus 2t plus c2 1, 2, 4 e raised power 2t plus c3 1, 3, 9 e raised power 3t. So this is x of t. But the interpretation of x of t means is a vector x1 of t, x2 of t, x3 of t. So putting together this, we'll have c1 e raised power minus 2t plus c2 e raised power 2t plus c3 e raised power 3t, and then minus 2c1 e raised power minus 2t plus 2c2 e raised power 2t plus 3c3 e raised power 3t, and the lower row will be 4 e raised power minus 2t plus 4c2 e, so there's a c1 here, so 4c1 So 4c1 e raised power minus 2t plus 4c2 e raised power 2t plus 9c3 e raised power 3t. Please note that this arrangement, this represents the function x of t. This represents the derivative of the function x of t. This represents the second derivative of the function x of t. So therefore, the general solution to the given problem is, so we pick the first row. That's what defines the solution to the problem. See where x of t is given by c1 e raised power minus 2t plus c2 e raised power 2t plus c3 e raised power 3t. So that is the solution to that given problem. Thank you.